Hello, and welcome to Lesson 1A of Module 6, Solving One-Step Inequalities. Our objective for today is that I can graph solutions of an inequality, and that I can write inequalities from a graph of their solutions. So what is an inequality? It is a mathematical sentence that contains the symbols less than, greater than, less than or equal to, greater than or equal to, or not equal to. An inequality compares the value of two numbers or expressions using those symbols. The solution of an inequality is any number that makes the inequality true. There could be an infinite number of solutions to an inequality. There could also be a certain amount if we're starting to talk about compound inequalities, which comes up later in this chapter. Now, we're going to make two notes here when it comes to the way we represent inequalities on a number line. So when it is less than or greater than, we represent those with an open circle. When it is less than or equal to or greater than or equal to, it is a closed circle. So an open circle if it's just less than or greater than, closed circle if there's the equal sign. So let's start by writing some inequalities. Letter A, all real numbers P greater than or equal to 1.5. So we want to know P is greater than or equal to 1.5. And since it's already on the screen, let's look at letter C. All real numbers X that are less than or equal to 5. So X less than or equal to 5. Now, all the numbers that you've experienced so far this year are real numbers. These are numbers that exist. You can graph them on a number line. They can be fractions, they can be decimals, they can be irrational numbers like pi or the square root of 2. So they could be all these different kinds of things. They are all real numbers. The difference between real and things that are not real, the ones that are not real we call imaginary numbers, and that is something for you to pick up in a future math class. All right, letter B, we have an operation. The sum of t and 7. So we need to remember that sum means we're adding, and we've got t and 7, so it's t plus 7 is less than negative 3. Letter D, 4 less than means we're subtracting 4. A number y is greater than 10. So we have y minus 4. 4 less than y, where 4 below y is greater than 10. All right. There are 2 you-try problems on this page. Do them on your own and then come back and check your work against mine. Letter E, all real numbers y that are greater than 3. Y greater than 3. Letter G, 4 times the quantity x plus 3. Well, times the quantity meant we had parentheses, and we have x plus 3 on the inside of those parentheses. So you have 4 times the quantity x plus 3 is less than or equal to 11. Letter F. The difference of y and 4 is less than 8. So difference means we're subtracting of y and 4. So y minus 4 is less than 8. And letter H, quotient means we have division. So x over 7, the quotient of x and 7 is greater than or equal to 9. All right, let's take a look at the next one. We're identifying solutions by evaluating. So we are going to substitute these values into this inequality and see if they are true. So if we're substituting in negative 3, we have 2 times negative 3 plus 1 is greater than negative 3. 2 times negative 3 is negative 6, plus 1 is greater than negative 3. Negative 5 is greater than negative 3. Is that true? Is negative 5 greater than negative 3? No. All right, how about negative 1? So if we substitute in, we have negative 1 times 2, we've got a plus 1 greater than negative 3. So negative 2 times negative 1 is negative 2, plus 1 is greater than negative 3. So that's negative 1 is greater than negative 3. And that is true. Negative 1 is greater than negative 3. So how is the solution of the equation related to the solution of the inequality? The thing to look for here, or the thing to know, is it is the inflection point. Meaning it is where you go from not a solution to a solution. So this is the point on the number line that you're going to make your change at. All right. So now we're going to go ahead and do letter D here, where we're going to substitute in a bunch of values into the same equation or inequality and see if they're true. So we have negative 7 times negative 1. Sorry, we had 13 minus 7 times negative 1 is less than or equal to 6. So when we do that math, 13, negative 7 times negative 1 is plus 7. Is 20 less than or equal to 6? No. So our next value that we're going to substitute in is 0. 13 minus 7 times 0 is less than or equal to 6. Is 13 less than or equal to 6? No. Next up, 13 minus 7 times 1 is less than or equal to 6. So 13 minus 7 is going to be 6. Is 6 less than or equal to 6? Yes. And lastly, we are substituting in positive 1. So we have 13 minus 7 times, wait, hold on, nope, we're substituting in 3 this time. We just did positive 1. Is less than or equal to 6. So that's 13 minus 21 is less than or equal to 6. 13 minus 21 is going to get us a negative 8, which is definitely less than 6. So you're going to go ahead and do the you try down below, where you're substituting in those 3 values for x and seeing if it's going to be a solution. So letter E, we have negative 3 times 2 plus 6 is greater than or equal to negative 4. So you have negative 6 plus 6 is greater than or equal to negative 4. So 0 is greater than or equal to negative 4. And that's yes. If we substitute in 5, negative 3 times 5 plus 6 is greater than or equal to negative 4. Negative 3 times 5 is going to be negative 15 plus 6. And negative 15 plus 6 is negative 9, which is not greater than negative 4. And lastly, we have 10 thirds. So we have negative 3 times 10 thirds plus 6 is greater than or equal to negative 4. So you have negative 10 plus 6 is greater than or equal to negative 4, and that gives you negative 4 is greater than or equal to negative 4, which is true. All right. Now we are going to graph these inequalities, and then we are going to identify what we know about the point in it. So when we have x is less than 1, it's going to be an open dot at 1 because it's less than. And we are going to use a test point. And I always like to use 0 as a test point. Is 0 less than 1? Yes, it is. So that's the side we're going to shade. And we remember that we put arrows at the end of our line. Now, what do we know about this end or the point? It is not a solution. All right, now let's look at the second one. We have x is greater than or equal to 0, so it's going to be a closed dot at 0. Make sure your dots are nice and bold so they're easy to be seen, especially if they're an open dot. And it is greater than or equal to 0, so we're shading to the right. And our point is a solution. So the difference here is if you were to substitute in for the red line there, if you substituted in 1 to the equation, 1 is not equal or not less than 1. You could get infinitely close. You could have 0.9999999999999, and that would be a solution. But the moment you get to 1.0, you no longer have a solution. In the green line, however, 0 is greater than or equal to 0 because it's equal to 0. All right, let's look at the third one. We have x is greater than negative 3. So we have an open dot at negative 3, and it is greater than, so we're going to shade to the right. And the point is not a solution. And our last point here, negative 2 is greater than or equal to x. So we put a point at negative 2. Now, which way are we going to shade? It's saying negative 2 is greater than or equal to x. That means that would be the highest point. And if we read this from right to left instead of our usual way of reading in math from left to right, if we read right to left, we read from the variable's perspective, it's saying that x, our unknown, is less than or equal to negative 2. So we're going to be shading to the left. And our point is a solution. Now, I want to point out one thing. When you have the variable on the left-hand side of your inequality, as it is in the first 3, whatever direction your arrow is pointing is the direction your line is going. So you'll notice in number 1, arrow points left, line goes left. Arrow points right, line goes right. Arrow points right, line goes right. When the variable's on the other side, you're going to do the opposite, right? The arrow is pointing to the right, the line goes to the left, right? So when we read from the perspective of the variable, if the variable is first, the first term, you just follow whatever direction the arrow is pointing. All right. Now we've got letters A, B, and C as you tries. Please do them on your own and then check your work against mine. Letter A, we have x is greater than 7. So we're going to have an open dot at 7, and we are going to shade to the right. Letter B, we have an open dot at negative 4, and we are going to shade to the right. And letter C, we have 3 is less than or equal to n, so it's going to be a closed dot at 3, and it's on the opposite side, so we're going to shade the opposite direction, and this will also shade to the right, because n is greater than or equal to 3. Now, our next example is writing an inequality from the graph that we're given. So in letter A, I see that we're shading to, we're going to start with our variable, x. Which way are we shading? To the left or to the right? We're shading to the left, so it's going to be x is less than, and we want to know our point is -3, and it's an open circle, so it's just x is less than -3. Now, as we look at letter B, we're going to start off. We have our variable, x. We have our reference point. Our point is 0, and it is a closed circle, and we're shading to the right, so it's going to be greater than or equal to. X is greater than or equal to 0. And letter C, we have point at 4, and we are shading to the right, so it's going to be greater than, and it is a solid circle, so it's a greater than or equal to. All right, there are 2 you-try problems that I would like you to do, and then we check them against my work. So letter D, we have our variable x. We are shading to the left of the point -2, and it is a closed circle, so it's less than or equal to -2. And the last one, we have letter E. We have x, we're shading to the right of -4, and it's just greater than because it's an open circle. All right. Last section is to apply real-world scenarios. So in this section, first off, we have maximum occupancy. Maximum tells us that is the most. So our occupancy has to be less than or equal to 350 people. Letter B, we have some sort of airfare sale. We have fares as low as $29. So that means the fares are greater than or equal to 29. Now we look at letter C. We have a school zone speed limit. Your speed needs to be less than or equal to 20 miles per hour. And lastly, letter D, we have the 270 to win map. This is the Electoral College map for the 2024 presidential election. We see Illinois here. Our population declined, and now we are down to just 19 electoral votes because there's only 17 congressional districts, plus our 2 senators. Anyways, we need 270 electoral votes in order to win the presidency. So in order to be president of the United States, you need to have greater than or equal to 270 electoral votes. And we will find out shortly what the outcome of the 2024 election will be. So those are the end of your Module 6.1a notes. If you have any questions, please bring them to class tomorrow. Otherwise, have a great day.